In this video, we will talk about graph databases. We'll see at high level what are graph databases and their usage. Also, we'll try to see the comparison between graph databases and relational databases. Very basic question is, what is a graph? Graph is represented as a collection of vertices and edges, or we can call it a set of nodes connected by relations. The graphs are very expressive. It presents the connected data as we visualize, unlike the SQL and NoSQL databases that uses their own way of representing graphs. Here I am showing an example of connections in a social media application. This is very small representation of how people are connected on Twitter or LinkedIn. Though the actual scale for Twitter will be huge, but it gives an idea of how social content can be represented in graph format. We can see three people connected by follows relationships. Messages are also part of the same graph, though the properties of message nodes will be different from the properties of people node. For example, the people node can have properties like name, location, work experience, etc. The edges represent follower relationships. In this graph, the properties of people nodes will be different from the message node, and also the properties of edges connecting the people node will be different from the properties of edges connecting the message node. But one thing to note that the graph database can seamlessly adapt to such variations. Graphs are everywhere. Multiple range of scenarios can be expressed using graphs such as system of roads, supply chain, social graphs, space rockets, medical history of population, geo-representations. The data around us are highly connected, and if we start visualizing it, we'll see the huge application of graphs and thus the graph databases. The most popular graph database model is property graph model. This representation has nodes and relationships. The nodes contain properties in the form of key value pairs. For example, when we have seen in the earlier part of the video, the person node can contain properties like name, status, location, etc. The relationships are named and directed. For example, person-to-person connection can be termed follows. Message posted by people can also be related and can be called comment or responses. Not just the nodes, but also the relationships can contain properties. On a high level, the graph database space can be divided into two major parts. First is online graph persistence. These are accessed by real-time applications, where the applications are actively modifying the graphs in transactional way. These are called graph databases. These are similar to OLTP databases in relational world. Offline analytics here the data is accessed in batches. The engine that performs the data analytics is called Graph Compute Engine. The compute engine scans and performs the computations in batches. This use is similar to what we call data mining in OLAP, where we perform analytics on relational or data in other formats. As discussed, graph databases are online systems that are accessed by applications. These databases support CRUD operations on graph data model. They provide transactional capabilities and they are optimized for transaction performance, integrity of data, and availability. There are two features for graph databases that need to be considered when investigating database technologies. First is the underlying storage the graph database is using. There are some databases that use native graph storage and others which do not use native graph storage. Some graph databases serializes the data in form of objects or in form of relational database tables, and thus they do not represent the data how it is actually visualized in the graph format. On the other hand, the native storage database systems store the data in graph format physically on the disk. Other thing is processing engine that operates on the graph data. Native graph processing has significant advantages when it operates over native storage. The reason being the graphs are represented as it is visualized and there are no unnecessary disk hops related to indexes. Graph compute engines support global graph computation algorithms to be run on large data sets, such as identifying clusters in graph data or answering questions like average count of connections per user. Because of global queries, graphs are optimized for scanning and processing large amount of information in batches. This way, they are similar to other data mining OLAP systems. Some compute engines have storage layers, but most compute engines performs only processing. This picture shows the architecture of deploying graph compute engines. This architecture consists of system of record database with OLTP properties. This database supports queries from live application. At regular interval, the data is moved from system of record database to graph compute engine for offline querying and analysis. There are a variety of compute engines such as in-memory single machine graph compute engines, distributed graph compute engines. Now we will see the benefits of graph databases that needs to be looked at when exploring databases. The motivation exists in the form of set of use cases that can be solved using the graph databases. The performance improvements and agility helps in handling the changing business needs. When dealing with connected data, graph databases have performance edge over relational and non-relational databases. As the data size increases, the performance of RDBMS-based join queries degrades significantly because of multiple disk hops required for answering the queries. On the other hand, graph databases performance remains constant because the connected data are stored together, which lead to faster query performance. The graph databases are flexible in terms of structuring the data and data schema and thus support easy evolution. Also, they do not have upfront contracts as RDBMS databases have. This helps in moving the businesses faster. Graphs are additive, add new relationships, nodes, subgraphs at any point in time. Plus, there is no need of upfront detailed domain modeling. It does not impact the existing queries and applications relying on the current state of data. This way, graph databases provides the required flexibility for the businesses. Talking about the agility of graph databases, graph data model is schema-free and provides the testable queries and APIs, and thus enable applications to evolve. Graph databases lack schema-oriented data governance as we see in relational databases. The data governance is applied in programmatic fashion. Graph databases provide tests to drive the data model and queries. Programmatic assertions from graph-dependent business rule helps in proper sanity checks on data. This covers brief introduction to graph databases. I will bring more videos on graph databases which will touch different topics in more details. If you enjoyed this video, please consider liking it and subscribing to the channel. Thank you.